Hey 8th graders, especially DLI kids and any A or B cohort that are gone the day we do the Newton Second Law mini labs, you guys will be doing this version here. So if you guys see the note at the top, A or B, do only the lab parts assigned in class. So you guys will each have either part A, part B, or part C to do in class and report your data. DLI students, however, won't be in class, so you guys will do only part C, which is the racing ramp. You will also need to use the video linked for your guys' data for this. So if we go ahead and scroll down to Part C, Racing Ramp. So the purpose says, in these labs you will be studying the effects of force, mass, and acceleration on the motion of different objects. So this is Newton's second law. It basically talks about force equals mass times acceleration, or how those three variables relate to each other. So in the labs today, whether you're doing A, B, or C, or in your guys' case C, we're looking at how two factors of that change when one factor is changed. So you guys will be keeping one thing constant. So out of force, mass, and acceleration, one thing will remain constant every test you do. You won't change it. And then you guys will be directly manipulating one factor. So again, out of force, mass, and acceleration, you guys will be manipulating one thing, and then you'll be observing the effect of that change on another factor, which we call the dependent variable. So again, out of force, mass, and acceleration, it's kind of what you guys are collecting data on. Okay, so for this to collect data, you guys will watch another video. It goes pretty quickly through the data, so pause as you need. And you'll be racing a series of 3 balls down a ramp, so you guys will be basically versing 2 balls against each other and seeing which one goes to the bottom and hits the finish line first. Okay, again, in science, you guys want to do several trials, and you'll see in the video why more than one trial is needed, because sometimes you make mistakes, and you'll also see some anomalies or things that are outliers. Because we are humans, there is such thing as human error in science. We didn't have a machine dropping our balls, but essentially they should have been released at the exact same time. So that might affect it as well. Okay, so we set up our 2 ramps on the seat of a chair. And again, each ball was dropped from the same position at about the same time. So you guys will record your data for trial 1, trial 2, trial 3 for each of these races. And then you'll pick an overall winner. Okay, you might see ties as well. And then what did you observe? So just give me a brief rundown of what you saw in those. Okay, these are the main things I wanted to go through with you here, is again, this concept of constant, independent variable, and dependent variable. You guys might also hear the independent variable called the manipulated variable, and the dependent variable called the responding variable. Okay, so for these answers, you will only use the terms force, mass, and acceleration. Once you have used that term, you won't use it again. So questions 2, 3, and 4, again, the answer to those are either force, mass, or acceleration, but you will only use each of those words once. Okay, so when we talk about a constant in an experiment, the constant is the one thing that we want to keep the same in every experiment. If we were to change multiple things at the same time, we might see a result and not really know where our result came from. So we only want to change one thing at a time, and that's called our independent variable. So the things we don't change then are our constants. In this case, between force, mass, and acceleration, only one of those are a constant. So in this case, we're dropping the balls from the exact same spot at the exact same time. Okay, so out of force, mass, and acceleration, which one are we holding constant and not changing every test we run? Okay, the independent variable is the thing that we're directly changing as scientists. We have gone in, and when we designed this lab, or when I designed this lab, I picked different objects to use. Okay, so what does that represent as far as our manipulated variable? What's the thing out of force, mass, and acceleration that we are changing in this lab? Okay, directly. And then our dependent or our responding variable is the effect of this change right here. So if we change the independent variable, okay, what effect will we see? That's our dependent variable or a responding variable. Easiest way to remember dependent variable is to think of what data you're collecting. Generally, the data you're collecting is your dependent variable. So again, out of force, mass, and acceleration, you guys are obviously seeing who won the race. So which one of those 3 relate to who won the race, force, mass, or acceleration. Okay, Last but not least, again, the only terms you're going to use for question 5 are force, mass, and acceleration. You're going to not use one of those. Okay, so this just talks about the relationship. All right, we had one constant and we had an independent and a dependent variable. So let's just talk about the relationship between our independent and our dependent variable. So what you guys will do is fill out this sentence and then you guys can choose whether you want to go with increased or decreased. Either one is fine, either one is correct. You guys just have to choose one and then the rest has to fit that same trend. So say I chose increased. I'm going to go ahead and highlight increased. Okay, so as we increased the blank, so the independent variable, so I'd look back and say, all right, what was my independent variable? As I increase that, okay, what happens to our dependent variable? Okay, so you would fill in your dependent variable, whatever you chose right here, in this blank, okay? Your dependent variable responded by, and then this one does matter, so you can't just choose which one you guys want to pick for this. You guys will choose the one that you actually see in that trend. So if we increase the independent variable, what happens to the dependent variable? Did it increase or decrease? So highlight one there. When you guys get that done, turn it in, and if you have any questions, please let me know. Thanks, bye.